For the 4 o'clock news and politics show this Wednesday during the holiday week. At 3 o'clock, we had The Taste, as we do each week with Rick Simone, talking about food trucks and late night eats. I have a feeling it will come in handy come New Year's Eve. We had Haven Brothers barbecue, popcorn, and more, so be sure to check out that show, all the best of local food. But speaking of things that are local, it's very cold up here in New England right now, but I have with me here in studio via Skype Vadim Levin down at Rutgers University, geophysicist there, who just made an interesting discovery about what's taking place up here in New England as it pertains to hot rock under the surface. Vadim, thanks for joining us today.
My pleasure.
So talk with us a little bit about your recent findings that were recently published in December regarding this hot rock in New England. A lot of different sites seem to contextualize it differently. But what made you look up here, and what exactly did you find?
Okay, so I'm an earth scientist, so my point of interest, my topic of study is our planet. This was a project done in collaboration with my colleagues closer to you than I am right now in Yale University, Maureen Long and her students. I have to give them a shout out, which is required. This is part of a national program called EarthScope, which was an attempt to understand what is beneath the land we live on at a scale that has not been ever attempted. So it was a continent-spanning experiment to understand the interior of our planet, and we wanted to see what's inside. Largely, well, it's both curiosity-driven, but also sometimes it helps us understand what to expect from Mother Nature in both good ways and bad ways. In this particular case, we were looking at distribution of properties very deep in the Earth, about 100 miles.
Okay.
And we mapped out an area that, on one hand, appears to be much warmer than the remainder of the area we looked at. And we were able to also show that not only is it warm, but it seems to be rising towards the surface. Now, before your listeners, readers, viewers get all excited about things rising, it is doing it very slowly. It's been doing it for a very long time, and it won't get there anytime soon. So no Yellowstones, please. Unfortunately, I have to keep repeating this when I talk to people. However, it's very gratifying that studies of technical nature like ours get sometimes picked up by news media. So it's a pleasure to talk about both the fascination of doing pure science with government support. I have to say that this is federal program, federal money, your tax dollars at work. And also with large participation of undergraduate students. There are 5 authors on a study published in geology, 3 of them are undergraduates.
So talk with us specifically in New England. I saw a number of entities reporting on this as well. And before we go to where exactly it is, let's make sure we get the terminology right here, because we've seen everything from hot molten lava, which it is not, to a hot rising blob. What is really the best contextualization of what is exactly going on under the surface?
Well, the term blob is purely scientific and correct indeed. The science that I do is called seismology. So I use vibrations from very distant earthquakes to look at what's inside the Earth. For Earth scientists, it's akin to light for others. So imagine taking a telescope and pointing it down so we can see what's inside, and we can see differences, shadows, shapes. So we were able to map out a shape that is, I don't want to go into too many technical things, but it's warmer than, let's say, areas east, west, and north of it. North, south, and west. It's difficult to say about the east because there is a coastline and we don't have instruments in the water.
Yes.
But still, it's a volume maybe a couple 100 miles across. It sits deeper than what we think is the thickness of the Earth's tectonic plate is, those rigid things that move around the surface of the Earth and make our mountains and create oceans when they separate and cause earthquakes sometimes. But there was a number of somewhat excited renditions of this study saying, jet of molten rock goes up. Please don't record it because no.
No molten rock.
It is all rock. It is all solid. Hopefully, we'll never be able to dig so deep as to open it up because 100 miles is really far. And the differences in temperature still are significant, a couple of 100 degrees, maybe 300 degrees Fahrenheit. And what results from that is that warmer things want to rise. What was nifty and pleasant and exciting for scientists like me is that when we thought, well, it's warm, it should be rising, and that we're able to come up with a particular measurement that told us, yes, it actually is. This is a rare case when your perceived notion is fulfilled. I believe it was Einstein who said that when your expectation is fulfilled, it's pleasant, and when it's not, it's interesting. This was pleasant.
This was pleasant.
Mostly we work on the interesting side of things, of course. It's on the technical level, it was an interesting accomplishment that we could prove that something that should be moving is moving. Now, moving on geological timescale, it creeps millimeters per year. Of course, the Atlantic Ocean does that too. It opens about this much a year. Let me show it to the camera. But if you sit there long enough, well, now we have to fly for 6 hours from one end to the other. So this thing is moving slowly up and may or may not get here before it cools off completely. We won't be around to see it, obviously.
There's not going to be any explosions, if you will, but probably, as you mentioned, really kind of garnered the interest, especially here in the Northeast. And it was kind of upper Northwest Massachusetts, Berkshires in New Hampshire, yes?
The place where the effect is most clear and most pronounced is somewhere on the border of Vermont and New Hampshire.
Okay.
The overall area is leaking, if you will, a little bit into I think it's limited by the Adirondacks, so Lake Champlain Valley. We can only see as well as our instruments permit. They were placed about 50 miles apart. Some of your listeners or viewers may have actually hosted those instruments. 2 years ago, they were in the ground from 2013 to 2015, and I know a lot of landowners were gracious enough to allow them to be placed on their land, so that was great, thank you. So that's what happened. The interest in this is that the basic theory we teach in introductory geology classes does not yet have these small bubbles of warmer and colder things in it. We think of our planet as more uniform inside, and as we get better eyes, we see it better and we discover new things. So this is kind of this pure joy of discovery there.
So you found it, and as I mentioned, a blob. You can really call it a blob?
That's wouldn't go into a title of a science paper probably, but I definitely would put it on a poster, which I give at a conference. And, a thing that is more roundish than long and doesn't have a well-defined geometrical shape. Okay. If you can suggest a better term, I'll be happy to credit you.
No, I like it. It's what I read, I believe, in Live Science about it. And I was like, it's a blob. Now, talk with us a little bit. This instrument and this sort of measuring device, you did this all around the country, did you not?
Right. The EarthScope program is it's still alive and active. It's currently moved its focus to Alaska. It started more than a decade ago. It was a massive undertaking. So devices that I used are sensitive to ground vibration. They're called seismographs. And we have a permanent network of them in the Northeast, but not close enough to see things like that. The EarthScope effort was to, more or less as the name suggests, image the inside of the Earth, at least in the land. It first swept the 48 states and now moved to Alaska. And as one of the analogies I came up thinking about how to describe this, well, before that, we had little flashlights in a dusty room and we could see details. Now we had an overhead, like a track light on top. And so you could really see everything at once with the same kind of illumination. So it allows you to avoid traps like, oh, my place is so very special. It allows you to compare one region to the other. We're now convinced that the New England is very special. There are a couple of other similar blobs that sit further south along the Atlantic coastline, and we, at the moment, don't have a good accepted, at least agreed upon explanation for why they're there.
Mm-hmm.
This is where the next generation of my colleagues will go. It's always exciting, especially when you get students involved, to say, look, I mean, we didn't know it was there 5 years ago, and now we do, and we don't have a good explanation for it, so you think about it.
So talk with us a little bit about that, going around and measuring it. As you mentioned, you had the measuring devices here in New England. Now the project is up in Alaska. When will this be re-looked at? Again, you sort of mentioned the next generation of scientists, but when's the next time folks like you are going to come in and, get that periscope, get the right looking down there? When do we think that's going to happen?
It always comes back to money.
Yes.
Somebody needs to pay for this. This was a massive undertaking, and it included a staff of professional instrument operators, maybe 10 to 20 people.
Okay.
If anyone's interested, earthscope.org is the website. It contains a gloat of wonderful imagery and very neat animations. Their public outreach department is extremely creative, and they have excellent visuals, great for teaching, for instance. But the return here, we are discussing a possibility of doing it on a local scale with my colleague Maureen Long from Yale, with whatever funds we can scrounge around. But it really comes down to having equipment and having money. We have no shortage of willing students. They are very excited about doing things. Geology is a pleasant discipline. You work outside, well, maybe not today.
Not today, not here.
Although when things are frozen, they actually are sometimes easier to deal with.
Really?
But, well, less dirt.
Less dirt, okay. It's true. You do learn something new every day.
But yeah, the next step would be to first think a little bit and maybe do some computer games with it, but definitely come back if we can find funding and can find willing bodies to go plant, devices in the woods.
So talk with us a little bit. You mentioned that EarthScope website being very interactive, very accessible. To findings like these, you work currently with an existing cohort of young scientists. But do you think this will really, get young students especially excited at the elementary and high school level, saying, maybe I might want to be a geophysicist?
Well, indeed. I think a lot of the excitement at the moment is in learning about both our homeworld and the new ones we're finding. And as always happens in these cases, to understand other planets, we may want to know more about our own. So as we start venturing to Mars and maybe other planets or solid bodies of our solar system, if we know more about how our world works, we can draw comparisons. So this is where probably the most exciting part is, to show how this planet that has us is different from other planets that don't have anything like us. Maybe there is a reason. I'm sure there is a reason. We just have to still work all of these reasons out. This is how I would pitch it to the people who are still entering, the world of knowledge, be they, grade schoolers or maybe introductory geology students. It's also important to understand what shaped our world in the past. Where do we go look for good things? Where do we worry about bad things? More knowledge is always better. So yeah, it's been a tremendous boon to the science that I do, the EarthScope program. It also showed how you integrate different disciplines, it required technological advancement of data transmission, storage. It's open data, so anyone can go use them. They're stored in an open archive. So this is a very kind of community-oriented way of doing research. So I can talk about it all day.
Well, it is very exciting, and of course kind of garners the attention, imagination, if you will, especially of us up here in New England. But as you mentioned, it is a blob, it is rising very slowly, no explosions anytime soon. But before I let you go, Vadim, I do have to ask you, a lot of folks are curious about Yellowstone. There's a lot of speculation about Yellowstone. Is there anything we should know about Yellowstone?
Well, Yellowstone, of course, is really far from us, and the last time it threw ash around the country was about, my dates may be fuzzy, but it's within the last million years, but not more recently than that. What else is to say there? That we have it covered with instruments, and people who do watch it every so often get very excited about a new bout of little earthquakes there or some changes in the gas chemistry. It is definitely a volcanic center in the middle of the continent. What, if ever, it will do again? Well, hopefully nothing. As long as we are all alive and our technology is as it is, hopefully we'll figure out a way to. I mean, when it did blow up very, 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 very long time ago, by human standards, it did create quite a calamity, but that's been well before humans could care about this because we didn't exist.
Well, do you think that people is it being ginned up as being a potential threat? Do you think that people just maybe need to chill?
Yes, chill is today, yes. They probably warm up, but in general, trying to imagine that a geological process will choose to change its behavior in our lifetime, it, I think, is a bit of a hubris. Yes, we are all very special, but if it didn't do anything for the last 500,000 years, why should it start doing it tomorrow? Possible, but no more possible than many other things happening. So understanding, learning, trying to predict the behavior is essential. Panicking, no.
Don't panic. Don't panic about the hot rock under New England.
Let the thought of it warm you up on a chilly day.
It is certainly chilly here in downtown Providence, but as always, we appreciate getting experts and especially knowing of hot rock here in New England. So Vadim Levin down at Rutgers, I appreciate your taking the time to Skype in today. Hopefully we'll speak with you soon.
My pleasure.
Okay, thanks Vadim. Take care. Okay, Vadim Levin, geophysicist down at Rutgers, talking with us about the finding of hot rock rising very slowly under New England, but part of a larger project. It was a pleasure talking with the professor. Don't go anywhere. We'll be right back in the Navigant Credit Union broadcast.